everyone, welcome back to my channel Size App. So this is another video dedicated in the series Distributed Systems, and today we will be talking about caching. So before I begin, I have to ask you that you like, subscribe, and comment and share my videos so that I can continue making more to help you ace your interviews. So today's topic is caching, and I'll go over what the basic concepts are, how it's used, and the regular. So let's begin. So load balancing, if you watch my previous video, it helps you scale horizontally across an ever-increasing number of servers. But caching will enable you to make vastly better use of the resources you already have, as well as making otherwise unattainable product requirements feasible. So caches take advantage of the locality of the reference principle. So recently requested data is likely to be requested again. So they are used in almost every layer of computing, hardware, operating systems, web browsers, web applications, and more. A caching is like short-term memory. It has a limited amount of space, but is typically faster than the original data source and contains the most recently accessed items. So caches can exist at all levels in an architecture, but are often found at the level nearest to the front end, where they are implemented to return data quickly without taxing downstream levels. So there is something called the application server cache. So placing a cache directly on the request layer node enables the local storage of the response data. So each time a request is made to the service, the node will quickly return local cached data if it exists. So if it is not in the cache, the requested node will query the data from the disk. So the cache on one request layer node could also be located in both memory, which is very fast, and on the node's local disk, faster than going through a network storage, for example. Well, what happens when you expand this to many nodes? So if the request layer is expanded to multiple nodes, it's still quite possible to have each node host its own cache. So however, if your load balancer randomly distributes requests across the nodes, the same request will go through different nodes, thus increasing the cache misses. So two choices for overcoming this hurdle are global caches and distributed caches. Now, the next thing I want you to learn is content distributed network. So the CDN, or content distributed network, are a kind of cache that comes into play for sites serving large amounts of static media. So in a typical CDN setup, a request will first ask the CDN for a piece of static media. The CDN will serve that content if it has it locally available. If it isn't available, the CDN will query the backend servers for the file, cache it locally, and serve it to the requesting user. So if the system we are building isn't large enough yet, we have its own CDN. We can use a future transition by serving the static media of a separate subdomain, such as staticyourservice.com, using a lightweight HTTP server like Nginx, and cut over the DNS from your servers to a CDN later. Now, what a DNS is, I will touch base later. But for now, this is what a CDN does, a content distributed network. Now, cache validation. So while caching sounds like a very fantastic idea, it does require some maintenance for keeping cache coherent with the source of the truth, which is the database. Like, how do we know that the cache is serving the request that's most recent, for example? So if the data is modified in the database, it should be invalidated in the cache. And if not, this can cause some inconsistency in application behavior. So how do we solve this problem of cache inconsistency? So there are many schemes, but three of them are the main and most used and most widely accepted. So first is the write-through. So under this scheme, data is written into the cache and the corresponding database at the same time. So the cache data allows for fast retrieval, and since the same data gets written in the permanent storage, we will have complete data consistency between the cache and the storage. So also the scheme ensures that nothing will get lost in case of a crash, power failure, or other system disruptions. So although write-through minimizes the risk of data loss, since every write operation must be done twice before returning success to the client, the scheme has a disadvantage of higher latency for write operations. So higher latency means it will be slower once you request information or for write operations. The second scheme to handle cache inconsistency is write around cache. So this technique is used to write through cache, but data is written directly to the permanent storage, bypassing the cache. And this can reduce a cache being flooded with write operations that will not subsequently be reread, but has a disadvantage that a read request for recently written data will create a cache miss and must be read from a slower backend storage and experience higher latency. So what will happen, the user sends a request, it will miss the cache, go to the backend, and then loop back when it's coming back to the user, it will write that information in the cache, which is called cache around. Like you go around the cache and you write and you come back. The third scheme is write back cache. So under this scheme, data is written to cache alone and completion is immediately confirmed to the client. So the write to the permanent storage is done after specified intervals or under certain conditions. So this results in low latency and high throughput for write-intensive applications. However, this speed does come with the risk of data loss in case of a crash or other adverse event, because the only copy of the data written is in the cache, so which is quite risky for most applications right back. Now, to discuss cache eviction policy, these are very important for you to know. There are so you're loading all this information in the cache, but how do you define when to remove data from the cache? So that's what the eviction policy defines. So the first of, there's 6 of them I will discuss. The first is first in, first out. So the cache evicts the first block accessed first without any regard to how often or how many times it is accessed before. So it's called first in, first out. It comes first, and that will be the one to get evicted. It's called FIFO. The second one is last in, first out. So the cache evicts the block accessed most recently first, without any regard to how often or how many times it was accessed before. So if it was the last one in, it's going to be the first one leaving. That's called LIFO. The third one is least recently used, which discards the least recently used item first. This is, in architectural perspective, this makes the most sense to me, because the one that's least recently used, it means it's not being accessed as frequently as the other items in the cache. The fourth is most recently used. It discards in contrast to least recently used, the most recently used items first. There are some use cases when this eviction policy might make sense for your architecture or for your cache architecture. The fifth one is least frequently used, which counts how often an item is needed. Those that are used least often are discarded first. This is quite similar to least recently used or least frequently used. And I'll discuss the differences when I discuss cache at more length. Number 6 is random replacement. Randomly selects a candidate item and discards it to make space when necessary. So now now you know the basics of the cache eviction policies, how cache is invalidation happens, and let me see how much time I have left. So this is it for caching today. I will be discussing more on caching actually I have 2 minutes, so I will go on with it. So now load balancing, as I've said, helps you scale horizontally across ever-increasing number of servers, but caching will enable you to make vastly better use of the resources you already have. So this consists of pre-calculating results, the number of visits from each referring domain for the previous day, pre-generating expensive indexes, and storing copies of frequently accessed data in a backend server like Memcache instead of PostgreSQL. So there are in-memory cache. Now, what is in-memory cache? The most potent in terms of raw performance caches you will encounter are those that store their entire sets of data in memory. Memcache and Redis are both examples of in-memory caches. Redis can be configured to store data, some data to disk as well, but that's a different discussion. So this is because accesses to RAM are orders of magnitude faster than those to the disk. than those to the disk. So on the other hand, you'll generally have your less RAM available than disk space, so you'll need a strategy for keeping the hot subset of your domain in your memory cache. So the most straightforward strategy is least recently used and is employed by Memcache. So LRU, least recently used, works by evicting the less commonly used data in preference for more frequently used data, and is almost as appropriate caching strategy. So for today, I will leave it at that. So caching, just know that it's a mechanism that's used so you can have it will enable you to make better use of the resources you have by making the data more easily available than having to go to the backend. So for now, that's it. Please like, subscribe, and share my videos. It will mean so much to me. And I hope to see you next time. Bye.